Hello, welcome to question 4. Sponsors in the top corner, Grays Hockey. Of course they are. Right, Scarfell Pike in the Lake District is the highest mountain in England. The maximum daily temperature in winter, W, at this place can be modelled by a normal distribution with mean 2.5 and standard deviation 1.4. State the percentage of days in the winter you would expect this place to reach a maximum temperature within 2 standard deviations of the mean. So this is on the old normal distribution. We know that between 1 standard deviation or within that is about 67, I think, percent. And then the 2 standard deviations is 95%. So that's something that we should know through our lessons. Though you could try and calculate that using the using the standardized normal distribution. And then you just put your high and low to 2 and -2, and that would get you there. Okay, so calculate W is less than 1.5. So X is going to be normally distributed, and we've got a mu figure of 2.5, and then our standard deviation is 1.4. And then what we'll put into our calculator is we're going to put a low in. Now this is quite interesting. So for the low value, I put -500. And the reason for that is if I go 2 standard deviations below the mean, I'm going to get a number that's negative for that temperature. And therefore I've gone really, really low in order to ensure that I've captured everything. And then the high value is going to be at 1.5. So what I'm saying is these don't just start at 0. That's not true for all of these graphs. Once I've put that into the calculator, I get 0.2375, which I'm going to round to 0.238. Why not? Treat myself. Okay, for this next one, we've got a low value of 5.3. We keep all the data the same. And then we'll have our high value. I put it as 20, and that gives us 0.0228, which is 0.023 when I round it to 2 significant figures or 3 decimal places. Okay, this one's probably the easiest one, part D. So all we need to change there is our low and our high value, and the low value will be -0.5. The high value will be 5.5. And then when we put that into the calculator, we get 0.968 out of there. Okay, the maximum daily temperature can be modelled by a normal, this is in summer, normal distribution with a mean 12.7. So mu is 12.7 and the standard deviation is 2.1. Now it's given as a probability, we need to work out the value. So we're going to have to go to the standardized normal distribution. And then we know our value is going to be quite low, and it's going to be in this section here, and that area is 0.04. So we put this into our standardized. In our standardized, mu is going to be 0. The standard deviation is 1. We're going to use our inverse normal. I'm just going to do that on the calculator while I'm with you, actually, just want to double check while I talk you through it. So the inverse normal, the tail you want is on the left. The area is 0.04. We've got the standard deviation of 1 and the mean of 0, which gives us -1.75. It carries on 0.068, but I've just rounded it there. Now, that means that once we put, in fact, I rounded it to this number, -1.751. So let me go back to our formula where we're going to convert this from the normal, from the standardized normal distribution back into the data that we're using. So we're going to just uncode it. So x take away 12.7, which is our value of our mean, and that's divided by 2.1, which is our standard deviation, and that will give us -1.751. So our process is to multiply by 2.1 and then add the 12.7, and that's going to give us a value of x equaling 9.0229, which I've rounded to 9.02. Okay, that's question 4 done. I'll see you at question 5, and if I don't see you again, good luck for your exams.